Okay, recording has started. Again, welcome to the study hall for February 7th, 2013. Two topics today, time permitting. The first is fraction decimal percent ratio challenge problems, including working together with these quantities especially. And then in-sentence correction, if we have the time, we will dig into some problems that involve, among other things, connecting punctuation. Okay, so as usual, we're going to cover the rules here. So submissions, the main guideline for submissions is think about whether your topic could reasonably last the duration of a study hall, or at least most of a study hall. That's the real thing that all of this revolves around, is could your topic last 60 to 90 minutes as a thing? So what this excludes is both things that are too general and things that are too specific. If you just send in one particular problem and there's not any sort of general inquiry surrounding it, that's not a study hall worth of material. And our goal here is to prevent the study hall from sort of devolving into like a bunch of random problems that have nothing to do with each other. So in order to keep that from happening, we don't want super specific single problems. We want those on the forum. So there's the address for the forum. If you have single items like that, that's where they go. At the same time, please don't submit things that are like the whole test at once. Finally, this is a thing that hundreds of people watch, sometimes even thousands of people in aggregate. So the other thing that's not really appropriate to discuss is personal study plans and things like that. Because again, this is not this Thursdays with Ron is not like a one-on-one consulting, tutoring type of situation. It's a general workshop that's meant to have general application to lots of different students. And so a single student situation would be sort of inapposite here. So consider whether your topic could last 60 to 90 minutes. If you do submit single problems, make sure you ask about some consistent thematic aspect of those problems. So if you just throw 3 random sentence corrections at us, then those belong on the forum instead. But if you throw 3 problems at us that include, say semicolons or something, then that could be a theme that we could conceivably think about covering. Same thing, if you throw a couple of problems about the median at us, and then you're like, okay, the median is the theme I would like to cover today. That's legitimate. So just make sure that there are themes is basically the idea, and that they are not so general. And don't forget, you can't use problems from the official guide. People have been doing this lately. It does tell you when you first log in to Thursdays with Ron that you cannot use official guide problems, and you really can't use official guide problems. So the best problems to use as submissions are problems either from our software or from the GMAT Prep free software, which is the other official material that you are allowed to submit. So from the last couple of weeks, here are some submissions that are not really things that we can use. This first question here, we basically have someone who is asking about the entire test at once. I want to write GMAT, but my quant and verbal are both weak. Suggest where to go. I mean, the problem here, of course, is that this is the entire GMAT. So there's definitely not any way we could cover the whole test or give someone a study approach for the entire thing in a single study hall. So this is much too general. This is just someone throwing 3 random problems at us. This kind of thing is exactly the reason why we have a forum. So each of these problems gets a separate thread on the forum, and then we will answer those in due course. So again, independent questions that do not tie into larger themes. That is why the forum is a thing. Finally, please don't submit official guide problems. It does say that at the start of the submission page. I mean, we're not really kidding about that, ladies and gentlemen. GMAC has explicitly asked us, please do not submit official guide problems online for free. Basically, it's their copyrighted paid material. The reason it's okay to use GMAT Prep is that that's free software. So they do not care if people are distributing those questions online, so long as you say where the question is from. But no OG problems. Even if it's a very good submission, we can't use problems from the official guide. So thank you for your understanding of these rules. Also, I think at this point we are pushing 80 of these recordings. I mean, there are a lot of them. So what this means is whatever your topic is that you have in mind, there's a very good chance that your topic is already in our database. So if it is, check it out. If there's a recorded video in the database about your topic, then please check it out before you submit your submission. If you don't know where to find these, you just go to the normal Thursdays with Ron page and you just scroll all the way down. I mean, they're all listed below the rest of the information about the study hall. All right. By the way, when we say give me a smiley face, we are talking about underneath your name. You should see these emotion icon things. In there, you should see a smiley face as one of the options, as one of the emotion icons that you can give. So when we say give me a smiley face, go ahead and give me a smiley face here, just to make sure you can find this thing. To make sure that everyone is kind of on the same page here and willing to move on to the next thing. Okay, smiley face, there they are. In other words, the point here is to not be drawing smiley faces in the chat box with 20, 30 people at the same time. So, excellent. Okay. The other thing administratively is that when we put multiple choice problems up there, you're going to see these polling items. So this is where you respond to problems A, B, C, D, E answers. So when there's a multiple choice problem, that means don't write your multiple choice answer in the box for everyone to see. Like when you do these, first of all, that's what lets us do those polling statistics on the board, like the bar graphs and all that kind of stuff. Second, no one will see what other individuals respond with when you do this. So you will see the class results when I post them, but other than that, here your answers are anonymous. I mean, you guys are kind of anonymous anyway because you're all usernames. But now it's double anonymous. Like no one will see what any individual person's answer is. So okay, if you understand all of those aforementioned rules, then go ahead and give me a smiley face. Again, this type of smiley face that is located there. All right, so again, in case you just showed up, a couple of you guys look like you just showed up. In case you did, the topic for today is some challenge problems that combine fractions, percents, and ratios, and then time permitting, we will jump into a certain amount of sentence correction with connecting punctuation. Okay, again, Ninad Shah. Give me a smiley face means please don't put the smiley face in the chat box. It means use that smiley face that is right there underneath your name. I mean, yours will not say my name, but your name will be here, and then you'll see this is a pull-down menu of face icons, and so that's where the smiley face will be found. Okay, so remember, when we have multiple choice problems for your pleasure and excitement, please answer them here. With those, there are multiple choice options once you click there. So please use those options. And let's go ahead and start with a problem. Go ahead and try this problem. So again, remember, here's where your multiple choice answers are found. And here's a timer. Go for it. Okay, ladies and gentlemen, please go ahead and pick some sort of answer to this problem. Remember, by the way, the GMAT doesn't let you not pick answers. So even if you're relatively new to this, especially, make sure you notice this. There's no such thing as a non-answer or a non-response here. Like, you have to pick something that is a thing. So even if it's a guess, that's how the GMAT works. You have to guess. So go ahead and guess if you have to guess. Take like 10 or 15 more seconds. Okay, so let's talk about it. Here are your class statistics. So people found this problem. Whoops, that's not the right option. Here are your class statistics. There you go. Okay, so it looks like we are kind of all over the place on this one. Again, we have 3 non-responses. One of the 4 non-responses down there is me, but if you are one of the 3 people who didn't answer the question, again, make sure you know, I think a couple of you may have just gotten here, but again, make sure you know that you are not, there's no such thing as a non-response on the GMAT. I mean, if you don't answer a problem, the test will politely and silently sit there and stare at you until you decide to answer it. So just make sure you know that's a thing. Okay, did anybody solve this problem in a way that doesn't involve algebra? If you did, then details in the chat box. Did anybody circumvent algebra? Someone says pick 100. Well, let's see what happens. So, Go Bruins, what was in your list? Go ahead and tell about that while we're looking at these other things. Okay, so one of our illustrious users here says, I picked 100. So let's talk about that real quick. That's kind of the idea that we're going at here, is the idea of picking numbers. So let's take a look at that. But at the same time, let's see if we need to make any alterations to that approach. So here, let's talk about this. So does anyone have any comments about that? Just picking 100, presumably for A. So if we do that, then what we get is, so if A is 100, then that's a very nice number to increase by a percentage. So B is 5% more than 100, which means B is 105. So in the case of B equals 105, I mean, if you do a prime factorization or whatever of this number, then you do discover that this number is divisible by all 3 of those primes that are up there. This number is divisible by 3, 5, and 7. So does that mean, I mean, there is no answer option that says all 3. So, So it looks like something may not be a thing. Does anybody have any thoughts? Yeah, how about 20 for A? See, here's the problem. The problem is that this says, and it's not really a problem with the method, it's just something you have to be very careful to pay attention to. And then it does say must be. So this means in all possible cases. So when you are picking numbers, I mean, picking numbers is a very legitimate way to do this. But when you pick your own numbers, you have to be very, very careful about picking numbers that reasonably give you an idea of what happens in all cases. So the problem with 100 is that it's not the smallest number that you can pick, and so when you do this, you have extra factors laying around that don't really have to be things. So if you look at 5%, note that 5% is 1 over 20. So as a fraction, because then as a fraction, the point is that it'll help you think about pieces of other integers. So that's 5 divided by 100, or 1 over 20. So the smallest possible value of A that will work here is A equals 20. And I mean, again, the example of A equals 20 is a good example to use because you know it won't have any extra things in it. You know, it's the smallest number that you can use, which means that it only contains the factors that it actually has to contain, which is, you know, a decently big deal here. So if A is 20, let's go ahead and just make a list. One of our users suggested making a list. Very good idea. So A and then B, which is 5% more than A, or 1/20th more than A. And so then factors are 3, 5, and or 7 factors of B. There's a list. So if we let A be 20, then B is 1/20th, or 5% of that is 1. So B is 20 plus 1, which is 21. 3, yes. 5, no. 7, yes. So you might kind of already see what's going to happen here, but if not, you should just investigate. You should just throw more numbers into the list and just see what happens. So the next number for A is going to be what Marcus says, which is 40. That's the next integer that you can take 1/20th of, or 5%. So 5% of that is 2, so B is 42. That's still a yes to 3. It's still a no to 5. It's still a yes to 7. At this point, you can generalize. This is the biggest advantage of making lists of stuff is, you know, aha, I see a pattern. If you don't see a pattern, you can just keep going until you see a pattern, which is the point of investigating with numbers. So basically, A is going to be some multiple of 20. And then B is going to be some multiple of 20 plus the same multiple of 1. So B is going to wind up being some multiple of 21. And so 3 and 7 are always going to be factors. But 5 may or may not be a factor. So this is going to be D. Any questions about that? Yeah, this is actually our problem, and so, right, Lynn points out that an answer of 1, 2, and 3 would be a good trap answer, and absolutely, I don't really know why that answer is not in the choices, so we will definitely do something about that and make it a choice that has a trap answer. In fact, that exact thought was going through my head. So, I mean, but sometimes, Lynn, I mean, yeah, on the GMAT, looks like someone erased the problem. Okay, time to take away the whiteboard permissions. All right, here's the problem again. Please don't mess with the board, ladies and gentlemen. Shouldn't really have to tell you that, but yeah. Okay, so here's the problem, and then we need to put it back in behind everything else. So there, all right. And then when you see must be, that means it has to happen all the time, and then that thing is now around the wrong answer. Okay. All right. Why did I select A as a multiple of 20? The reason we selected A to be a multiple of 20 is that you're increasing it by 5%. And so if we want to find the smallest number that you can do that to, because the point is to, if you pick the smallest possible number, the first thing is it'll help you discover this pattern. The second thing is, because we're looking for factors that have to be there. We don't really want extra baggage in terms of factors. And as you can see, that's the problem with picking 100 here, is that 100 has an extra 5 laying around. The 5 doesn't actually have to be there, but if you pick 100, it's there. So the point of picking 20 is that it is the smallest number that you can take this percent of and still get an integer, or the smallest number that you can take this fraction of, if you think of it as a fraction instead. So, any questions about this? Okay. So, all right, now let's, I think one person is typing, but, all right, let's go ahead and look at an algebraic approach. Don't forget the main point of going back and reviewing any of these problems, which is to figure out as many approaches as possible. So just to give a very brief recap of a discussion that we've had in greater depth in the other study halls. Remember, not when you're doing the problem, because you only have time to do the problem like one way. You can try other ways, but you don't want to solve all the way through a problem 2 or 3 times when you're under a timed conditions. But when you go back and review a problem without a timer, of course, the goal is to find as many ways as possible to solve the problem. And remember, the things you don't want to be worrying about here are faster and easier. And those are not things, basically. Those are really never things that you need to worry about, because they're not consistent from problem to problem. So, I mean, we're going to look at an algebra approach now, but even if you find this slower or more arduous or whatever than picking numbers, that's not really the point. The point is that you be able to do both, so that you can then use either approach if you are stuck on another problem later. So if we want to do algebra here, then we can write an equation that says B is 5% greater than A. And so if you want to use fractions to write that equation, then 5% greater than A means this. So in other words, B is equal to 21/20 of A. In the chat box, why fractions? I mean, what's the point of going to fractions here? Because when you think about percents, your first thoughts probably don't revolve around fractions. They probably revolve around decimals, which is what percents are usually converted into. So, yeah, Paul, because, right, we're thinking about factors here, right? Like if you go back to the question, again, make sure you're always aware of what is actually happening in the problem. I mean, that's another big thing, is people kind of forget about the environment of the problem. Like this is not just a problem about percents. It's a problem about percents as they pertain to the factors of a number, which is a fraction thing. So in this case, we want to know about factors or divisibility. And that's basically a fraction issue, or because it's an issue of dividing things. So decimals are not particularly useful in this problem, but fractions are great. So b equals 21 over 20a. If you multiply that, you get it 20b equals 21a. And notice that both sides are integers, because, 20, b and a are integers. So in terms of primes, 20 is 2 times 5 times b. And then 21 is 3 times 7 times a. So don't forget with primes, the point of primes is that primes are unique and primes don't tread on each other's territory. What I mean by that is you can't make up primes with other primes. Like if there's a 2, and a 5 over here, then let's see if I have a less obtrusive pointer. Okay, if there's a 2, and a 5 here, that means that somewhere in this junk over here, there are a 2, and a 5. In other words, the 3 and the 7 can't cover that. This is a special thing about primes. Like other numbers, that's why you break things into primes, because they do that. If you had numbers that were not primes, then numbers could cover for other numbers. Like 2, and 5 could be over here, but like 10 and 2 could be over here. But in terms of primes, you don't. So what this means is it means two things, one of which is a good observation to make in review, even though we don't particularly care. That observation is that A has to contain 2, and 5. I mean, the problem is not about A, but when you go and review it, it's good to notice this kind of stuff. So A must contain the prime factors 2, and 5. That's where the whole idea that A is a multiple of 20, that's why it has to be 1. And then similarly, there's no 3 and 7 over there on the left, so that means B has to have those in it. So there's your proof. So B must contain the prime factors 3 and 7. And you can also see, if you write this equation, you can see right away that the smallest possible values of B and A would be if A is actually 2 times 5, and B is actually 3 times 7. And those happen to be those numbers, 20 and 21. So it all ties together. I mean, we're discovering this in two ways that are totally different. Steve, if the right side had a 2 in it, you could just cancel the 2. And then you could simplify your observations accordingly. So, and then once you did get rid of that 2 that was on both sides, then that would be, yeah, that would be the correct conclusion. Okay, don't forget again, ladies and gentlemen, the point of reviewing the problem is to poke around and kind of figure out everything that you can figure out about it. Like not even just figure out as many ways to solve it, but also figure out like stuff that you might not even pay attention to when you're under time conditions. Like here we can investigate A and B when we're reviewing the problem. If we were doing the problem, this would be a very bad idea, because again, we don't really care about factors of A. So when you're under time conditions, the brown blanks here are just a waste of everybody's time. And the blue things are the focus. But when you're not under time conditions, it's a different game. I mean, the point becomes, let's just figure out as much stuff as we can about this. Any questions? If you have them, please type them in the box. Otherwise, we will move on. And yeah, we will edit the database so that there's a trap answer in that problem. Okay, so your answers are cleared. Here's a new problem. Okay, timer will show up shortly. Remember, here's where the answers are. ladies and gentlemen. I'm going to give you less time than usual because the problem is short. Go for it. Okay, take a little bit more time. Remember, the problem statement is short. I mean, that doesn't mean easy, and it also doesn't mean hard. It just means short. But when you have a short problem statement, the thing that you should get out of that is this should take less time. It doesn't necessarily mean it's easier. It just means it should not take as long. So try to finish this in the next little bit. Okay, out of like 22 people here, we still only have about 10 or 11 responses to the problem. So go ahead and pick something. It has now been kind of a long time. So we still have like 7 or 8 non-responses. Again, not to sound like a scolding first grade teacher here, but you cannot not answer the problem. You have to answer the problem. So you got to learn to love the idea of making a guess here. You know, it just is a thing. Okay, so here are the class responses. Again, there's still, besides me, there are still 3 non-responses here. So if you are one of those 3 non-responders, I mean, we can't keep holding up the class waiting for you, but just make sure that if that happens even a single once on the real test, then the timing of the whole exam will kind of go to heck really quickly. So you got to be very aware. This is a test of just kind of getting up and getting moving more than anything else. So we are, again, kind of all over the place on this one. So there's going to be some, I mean, there's no majority answer at all here. And in fact, the correct answer to the problem is actually one of the least popular ones. But we'll see. So apparently this is a challenge problem. Okay. What is a way to do this problem that is not algebra? See if anybody has an idea. Yeah, you can just pick a number for A. So let's do that. Let's try picking 4 for A. Sure, why not? Right? So you can pick your own numbers again. I mean, again, make sure that you know, I mean, knowing how to do things like pick your own numbers, one of the most essential things on the whole quant section of this test. Like, a lot of people make the mistake, and it definitely is a mistake. Oh boy, it's a mistake. A lot of people make the mistake of just studying math topics when they study the math of the GMAT. And I mean, that's really not such a great decision because, you know, the math is not really such an advanced thing here. I mean, you know, look at the math of the last problem. You had to know how to do 5%, and you had to know how factors work, but those are not advanced ideas. Same thing here, the only math you need is how to, like, increase something by a percent or decrease and find those percent decreases. But, you know, that's not the point. The challenge is not the math here. The challenge is the strategic angle. So really your entire job when you're doing these problems, it's no exaggeration to say that, your whole job is to figure out other ways to do these problems, not just to study math. So here you can pick your own numbers. Again, make sure you know why you can do that. You can do that because we don't ever find out the values of A, B, or M. So Paul is noticing that A has to be a multiple of 4. Because again, perhaps riding on the coattails of the last problem, but M has to be 75% more than A. So let's start there. M has to be 75% more than A. By the way, let's pause for a second and let's talk about this answer choice right here. Does anybody have any thoughts about that answer choice? Any thoughts? Tell me a story about it. Someone says illogical. I mean, the problem is that it's not really illogical. I mean, it might be illogical if you have an exceptionally amazing grasp of numerical intuition, but the problem is that this answer is very logical for a lot of people. And so it's what Elliot is saying. This is a trap. Okay, now, here's something, I mean, you don't want to circumscribe this sort of idea too precisely with rules and whatnot, but you just want to make sure that you understand this. Like, when it comes to choices like that one, the idea here is that if something is too good to be true, then it's not true. It's like real life, you know. Anything that looks like it's too sweet of a deal is probably not a deal. So, if it looks too good to be true, then, well, you know what. So, trap answer. I mean, in general on this test, you will notice this is how they roll. I mean, if there is an answer that's like, oh, that looks so obvious to me without doing any work, I mean, ladies and gentlemen, do not pick that answer. It's not going to be right. So, okay. In other words, if you're thinking that, oh, you know, M is the average, and so if one of the things is 75% more, then the other one's 70% less. Oops, yeah, no. So we'll see why not in a second, but way too easy. You should be very suspicious. So M is 75% more than A. 75% is 3/4. So this means that A, yeah, there's a fixed number, not percentage. Then, right, that's why we're, yeah, Paul, that's exactly the rationale behind this picking numbers method. That's why this works. Because for any fixed choice of number, it's got to turn out the same. So A has to be a number that you can take 75% of. So Paul says let's let A be 4. You could also let A be 100, but you could do either one. So let's let A be 4. So this means that M is 75% more than 4, which is 75% of 4 is 3. So M is 7. So these are very nice numbers. When you are dealing with averages, when you're dealing with averages of nice, pretty whole numbers like this, you don't really want to dig too deep into formulas if you don't have to. I mean, you can just think of this as a number line type of situation. So here's A, here's M, and then here's B. And we know these have to be evenly spaced because that's an average. So this is 4. The average is 7. So what's B? B has to be 10, right? Because that space has to be the same on both sides. I mean, you can also set this up algebraically, but it's sort of a pain. I mean, it's not... You should know how to do it anyway, because again, the goal here is to know how to do everything in every possible way. But the number line approach here is your friend. But you could, you know, the unknown here was B, so you could say the average of B and 4 is 7. So the average of B and 4 would be written as B plus 4. That's sum divided by 2. I mean, that's also a thing. That's a lot more work than just staring at a number line and being like, yo, there's the number. But again, you should be able to do both, is the point. So then B has to be 10. And the problem becomes how many percent less than B is M is the question. So M rather is how many percent less than B. So well, M is 7 is how many percent less than 10. So you could do a formula if you had to, or you could just look at it by inspection. By inspection. Inspection is a fancy way of saying you just kind of look at it and you're like, oh, I can do this. So it's 3 less. So 3 is 30% of 10. So 30% less. If you want to use a calculation, again, you should know how to use a calculation, because if you're ever doing this with variables or whatever, that's how it has to be done. But if the percent difference, it's the percent difference divided by the reference number. So by reference number, I mean, the number that you're taking the percents of here. So in this case, we're talking about percentages less than B. So B is, this is not a term. I mean, I don't know if anybody else ever has called that a reference number, but I'm calling it that now. So the reference number here is B because that's the thing you're actually taking percents of in this comparison. So the percent difference is 10 minus 7. And the reference number happens to be B, which is 10. So that's 0.3. Which is 30%. Okay. If it asked M must be yeah, okay, let's do that on the next page. Before we have that, does anybody have any questions about the approach that is currently on the board? Because we are out of space, which means that we will have to kill this page and move on to another page. So Paul will get you in a second. If anybody has any questions about what is currently up there, let's hit that first. Okay, it doesn't look like people do. So here's the question again that Paul is asking, and then here's the problem again. Okay, so again, the result was of the last method was we picked A is 4, which means that M wound up being 7 and B wound up being 10. And 10 is 7 rather is 30% less than 10. So Paul says, okay, I get what you're doing here. What confused me a little bit was this. I don't know if you happen to be like a programmer or anything, but I know that in like the only programming languages I know are like programming calculators and stuff. But I know that you can do things like M, then you do things to M, and then you like make that back into M again. Like M plus 1 equals M. The problem is in math, you can't do that. You can't make the same letter stand for different things before and after. So like this is, I get what you mean here, but like the point is that this M would be like the new M after you increase it, and this M would be like the old M before you increase it. So just make sure you know how these things would have to be worded on the exam. Like this would, they would have to write this as something like, by how much would M have to be increased to equal B? Because then there's M is not the after value is the point. You can't make it the before and the after. So m is just this number. So by how much would you have to increase m to equal b? And then, so yeah, that's what you would get. It would be, I think that's the approximate value, but it would be, you know, increase divided by reference number. So in this case, the reference number is m. Also, it would have to say by what percent. Not to be a jerk or anything here, but what is actually the answer to what's actually the answer to that question? Oh, it says percent. Okay. But if it just said how much, right now the hand is on top of the percent. If it just said how much, then the answer would be what? If it just said how much without a percent sign, yeah, then it would be, well, it would be 3. You would have to increase it by 3. You'd have to make it go from 7 to 10. So let me just write that on the board just in case that confuses anybody. Like, by how much? I mean, in general, there'd be no answer because m doesn't have to be 7. But yeah, by how much would m have to increase? So for this example, it would be 3, but in general, it would be I don't know. Or like Abhishek is saying insufficient. If this were a data sufficiency setup, then yeah, it would be insufficient. So in general, like for this example, 3. But in general, we don't know. Because again, A and M and B could be bigger numbers. So, but as a percentage, everything is fixed. All right, but back to this increase of a reference number, and with these numbers would be an increase of plus 3 divided by 7. So yeah, that's 3/7, which is my calculator says that that's actually about 42.9%. So 0.42857 da 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 da. So approximately 42.9%. But yeah, that's basically the idea. All right, now Lynn says, let's go ahead and make another page. Here's what Lynn has to say about this. So there's your problem again. Does anybody know, I think you guys probably know how I roll by this point, but does anybody know what my response to that is going to be? Of course, picking n is the best in this case. Yeah, I mean, it's not so much that there's no best way, okay, because for individual problems, there often is a best way. But the point is that you don't care which is the best way. Because again, the next problem is not going to work exactly like this one. So it's really important to not really clutter your brain with best or fastest or whatever, because those are only things that exist for one problem at a time. Like the best way to do this problem. The problem is the best way to do this one is not the best way in general. There is no best way in general. That's the issue. So, you know, it's the best way to do this one, and then as soon as you walk away from this one, oh well. Yeah, Abhishek, yeah, just a second, buddy. So with this one, you don't care. All right, we're going to do an algebra approach here in a sec, but Abhishek says the first page. There's the first page. So give me the smiley face or whatever when you're done with your screenshot. Okay, screenshot done. All right, so here is the, let's do an algebraic approach. So, okay, what this means is if m is 75% greater, then someone wrote this in the box already. I think, I want to say Marcos wrote this. If m is 75% more than a, then that means that m is, you can use either. Again, fractions, Paul says fractions are still better, right? This is another thing that you don't care about. I mean, you should actually try to, let me just stack it right on top of that other question. You still don't care. I mean, you want to try to get this to happen in as many ways as you can. I mean, fractions are not as essential here because there's nothing here that depends on the idea of fractions. Like in the last problem, you had factors of a number that were primes, and decimals are not really your friend there. But here, there's no factors, there's no divisibility, so there's no real compelling reason to use fractions, but you could still try it. So, and yeah, it's a habit thing. The most important point I can make here is the most valuable thing you can do is do the one that's not your habit. Like if you like fractions, then do decimals. If you like decimals, then do fractions. Not when you're under time conditions, but when you review the problem, you should totally do all the stuff that you don't like doing. That's the point. So, okay, m is 1.75a. Now, the way that you write an average is it's the two things you're taking an average of. You add them and you divide by 2. So that means, in words, this thing that we just wrote is 1.75a is the average of a and b. So that's what that is. So then you can multiply out the, you can just multiply both sides by 2. And that gives you 3.5a is a plus b. You can subtract a from both sides. So you get 2.5a as b. So the percentage difference, again, is it's the difference divided by what I decided to call the reference value. So it's a little bit annoying because these things are sort of treacherous decimal numbers. But, you got to do what you got to do, right? So if you do that standard calculation, the numbers are just a little bit uglier. So the percentage difference is the actual difference divided by the reference number. So that's b minus m over b. So that is 2.5a over minus 1.75a over 2.5a. Because again, we got that stuff from before. Like b, here's this. So b is those things. And then here's another fact from before, is that m is 1.75a, so m is 1.75a. And so that reduces to this. The a's cancel, so that's equal to just 0.75 over 2.5, and that's 0.3. If you you can move decimals over if necessary, but if you have trouble getting through this last series of steps, then make sure you consult our FDP's strategy guide, fractions, decimals, percents strategy guide, and then you'll get the help that you need. You can totally also do this with fractions. I'll just sort of verbally describe what happens there because it's very similar to this. It's just fractions instead of decimals. But if you use fractions, the sort of drawback there is that this is also a fraction. So for at least a moment, you're going to be dealing with fractions inside other fractions. But that's still a thing that you have to be able to do. So you should practice it. If you do fractions, you'll get m is 7/4 a. So you'll get 7/4 a is a plus b over 2. And then if you, oh heck, let's just do it on the board. Probably faster than all this talking about it here. there's your thingy again. What I'm going to do here to make this a little bit more efficient is I'm going to open up Microsoft Equation Editor and import equations from that. So there'll be a little bit of a moment of waiting. Okay. While I open that up. All right. So we have A is the by hybrid method, I'm assuming it means you just kind of did some sort of combination of both. So M is 75% more than A with fractions. Well, let's see what happens with fractions. So with fractions, we get M equals A plus 75% is 3/4. So M is A plus 3/4 A, which means that M is 7/4 A. So there's that. Oh my, that came out big. So M is 7/4 A. So then we need to write the average as, so M is the average of A and B. So if we write that as an equation, we get 7/4 A is the average of A and B. So that's A plus B over 2. And then if we multiply both sides by 4, what we get is 7A equals 2A plus 2B. So that'll show up in a second. Okay, so if you have this, then you can subtract and you get 7A equals 2A plus 2B, so we know that 5A equals 2B. And then we know that if you look at the approach that we took with percentages here, it's the same sort of thing. So now we're going to do percentage difference as B minus M over B again. So we just substitute accordingly. So that's going to be, well, we know that M is 7/4 A, and we know that B is, we need to solve for B. So divide that by 2. So B is 5/2 A. That's supposed to be a 2, not a 1. All right, so that's 5/2 A minus 7/4 A over 5/2 A. I mean, again, if that scares you, that doesn't mean don't do it. It just means get better with fractions so that it doesn't scare you anymore. So, but, you know, you do have this, at least for a moment, this sort of randomly uncomfortable fractions inside other fractions type of situation thing. But the way to handle that is just multiply out by a number that will kill all of the small denominators. So we can multiply that by 4 on the top and on the bottom. So times 4 by everything and times 4 by everything. So that is going to give us 10 minus 7 over 10. So that's 30%. So there's so many ways that we can do it. Let's see. Lynn says we can do algebra then pick a number. Yeah, you totally can. It just depends on where you see an opportunity. I mean, if you're doing algebra and you get stuck, then, like, let's say that you got stuck at this step here where you had to find a percent difference. I mean, then you can just decide, okay, I'm stuck. I don't really know what's going on here, so let me just throw numbers into that. I mean, you can absolutely combine them at any. I mean, you don't need to formalize it. You don't need to be like, okay, this is a thing that I'm calling the hybrid method, because you don't really need names or whatever. But the point is that you can absolutely pick numbers whenever you feel like it, as long as it's a quantity that you don't eventually find. Like if the problem was like, dude, what's the value of B? then you can't pick B, because if you picked it wrong, it would be wrong. But otherwise, yeah, you can totally just make up a number whenever you feel like making up a number. Okay, so lots of ways. There's a fraction way, there's a decimal way, and then there's a pick numbers way. I mean, this is the kind of reason why reviewing is a thing. You want to discover all of these before you really decide that you are done. Okay, let's do a data sufficiency problem. So this one you're about to see. Again, in these study halls, if anybody out there is a beginner, we do assume that you know what the answer choices are in data sufficiency, and at least we also assume that you know what the concepts of sufficient and not sufficient mean. In case anybody is a beginner, I'm going to go ahead and throw the answer choices up there, but if there is anybody out there who doesn't know yet what sufficient and not sufficient mean, then please, familiarize yourself with that. We have our intro materials, or you could just, do a bunch of problems until you sort of understand the idea. But just so these study halls don't slow to a crawl, we have to assume a certain amount of familiarity here. So here's your answer choices. You should have these memorized, but just the benefit of the doubt there. Give this a shot. And here's some time. Have fun. All right. Let's wrap it pretty soon. Again, you know what we're going to say by now, but you got to pick something that is a something. So, I'll give you a few more seconds to do that if necessary. Okay, so most of you have some somethings. Again, I think it might be the usual crew of non-responders here again, but remember there's no such thing as a non-response on the GMAT. So, all right, let's get that out of the way. Here's your class responses. There you go. So it looks like it's the C and E party here. Kind of undecided. We're almost exactly tied at C and E. That's kind of cool. So let's do it. So I mean, there are percents involved here, although honestly the percent angle of this problem is sort of weak. I mean, as soon as you take 60% of 65, then it's not really a percents problem anymore, but we'll get there. So we know we're going to have to do that, so let's get that out of the way right now. 60% of 65 is, you could do 0.6 on your paper, or you could realize that's 3/5 of 65. So 1/5 of 65 is 13, so it looks like 3/5 of that would be 39. Okay. We're going to have to figure that out, so I might as well just get that done. All right. So, what is the first thing that you have to do when there is a data sufficiency problem in front of your face? Chat box. What do you do first? Rephrase, probably, I mean, most of the time you generally aren't going to rephrase. I mean, rephrasing is a thing you're going to do some of the time, but most of the time you're not. So I mean, we got it looks like we got a bunch of people saying rephrase. Okay, grid, yeah, let's make the grid. Okay, that's not what I'm going at here, but you should do that too. Let's address this whole rephrase thing. Veronica is not the only one who said it, but I just happened to screenshot what she wrote. Is rephrasing, here's the deal with rephrasing. I mean, what you should do is kind of think about whether you have to rephrase. But here's the basic deal with that. If the question is like weird or awkward or cumbersome, then try to rephrase it. But if the question is not weird or awkward or cumbersome, then don't bother. I mean, in other words, if the question is already perfectly understandable, then there's no point in spending time trying to transform it into a different form. So, like, and I mean, again, this is a subjective judgment, but the point is that rephrasing is really a useful thing. The thing that's useful is rephrasing, it becomes a useful thing when it takes horribly awkward, weirdo questions and makes them less weird. So, like, as a couple examples of what I mean by horribly awkward, weirdo questions, like this. If you get if n is divided, but if the integer, positive integer n is divided by 2, is the remainder equal to 1? Does anybody know that that's a horrendously awful way of asking what? Does anybody know? Yeah, I mean, if you don't know that right away, you don't have to memorize that, but if you don't have it memorized or if you don't understand right away, just think about numbers that do that. Like the numbers that divide, they give you a remainder of 1 are like 3 and 5 and 7 and so on. So this just means, is it odd? So this is the kind of time when rephrasing is a thing. Like this question is clearly horrible, and it should be, on a moment's reflection, you should understand this is not what they're really asking me. So this is code for something else. Or if you get, you know, is x plus 3y equal to 3x plus y? That's kind of a weird question, but you can do some simplifying on that, right? You can take x and y away from both sides. So then you would get is 2y equal to 2x, which then you can divide by 2. So is x equal to y? Or, you know, was Carl at least 31 years old on New Year's Day 2011? I mean, that's kind of needlessly weird. So you can just go back to Carl's actual birth date. So was Carl born before 1980? So on the other hand, if the question is not very weird, then don't waste your time. Like if the question is already something like one of these, that, or that, or that. And I mean, most questions honestly don't need to be rephrased. A lot of them do, so that is a useful thing to think about. It's not like, oh, don't think about it. But it's not, oh my gosh, I need to rephrase every question in the world. In fact, you're going to get into a lot of trouble if that's your mentality, because most questions don't need to be rephrased. And if you, the real issue is that you got to be really careful with it. I mean, because if you rephrase a problem incorrectly, then it's all over. I mean, then you've lost the problem. So be judicious with it. Be careful. It's not like, you know, rephrasing is a pretty powerful cannon. You don't want to just fire it at everything in the world. So, okay. So here, I mean, we don't really need to rephrase this question other than maybe making that 50. So did it win at least 50 games? Now let me tell you where I'm going with this I'm going to go ahead and kill that rephrasing discussion there. When I say what do you do first, and I mean, whenever you look at our materials, make sure they're doing this whether they make it explicit or not. But yeah, you have to understand, okay, like the first thing you should do, besides the grid and all that sort of administrative stuff, yeah, you should make the grid too. Once you're a veteran at this, you probably honestly don't need the grid anymore, but if you're still relatively new to this whole game, then yeah, you should make the grid. But the first thing you should do is understand, and what that means when you are faced with a DS problem, is actually like clarify exactly what the goal is, exactly what would be sufficient, and exactly what would be not sufficient. I mean, this is really important because someone in the chat box has just said, could we count the number of games won? That's not, you don't have to know the exact number of games won, so that's not what we want. But someone tell me what would, and I mean, on yes-no questions, it's more concrete to define what not sufficient means first. So if it's a yes-no question, figure this out first. Because not sufficient means, you can get two specific things to happen. So what does not sufficient mean? Like, let's actually state what the goal is here. So yeah, it's the understand part of the understand, plan, and solve. So what does not sufficient mean here? Remember that yes-no questions, not sufficient. Well, don't give me yeses and nos, though. I mean, give me specific facts about numbers of games. That's the whole point. And I mean, it's not I don't know. That's the other thing. I mean, not sufficient is a definite thing. It means that you can definitely make blah happen, and you can also definitely make other blah happen. This is the problem, is people think these are vague, and they're not vague. So it doesn't mean the number has to be less than 50. It doesn't mean that. So it means you can get, in terms of yeses and nos, it means you can get yes and you can get no. But that's not really good enough. You want to make sure that you get from your yeses and nos into actual statements about numbers of games. So not sufficient means you, like the number of wins, the yes would mean the number of wins can be 50 or more. That's what a yes is in this question. And the number of wins can be not 50 or more, i.e. 49 or fewer. That's what not sufficient means. If you do not have this figured out, you are not ready to solve the problem. Is the audio weird? What kind of weird? What's wrong with the audio? Echo. Is that any better? Okay. Let's stick with that for the time being. Okay, if you don't have this figured out, you're not ready to start this problem yet. Really, really, really important. And then sufficient is only one of those can happen. In a yes-no question, only one of these results can happen. When you have a yes-no question, this is a good protocol to follow. Start by defining what not sufficient is, because not sufficient is these two concrete cases that you can get both of. And then sufficient means only one of them is a thing. So, again, I know I've said this like 18 billion zillion times already, but if you do not explicitly know that this is your goal, then you are not ready to solve this problem. So, and when people still, what am I doing, Ron? I am teaching the study hall. What are you asking me? If you don't have this figured out, then it's like trying to play, if you don't have that figured out, it's like trying to play soccer without knowing that you're supposed to put the ball in the net, you know, which, I mean, I don't know if I've made this analogy in these study halls before, but it's a really good analogy. Like, think about if you were an outer space alien watching a soccer game, and you really didn't know that putting the ball in the net was the point. I mean, there's two things that would happen. The first thing is you obviously wouldn't understand the game. But the second thing that would happen is it would look so much more complicated than it really is, because, oh my gosh, there are 22 players running around, and I have no idea why any of them are going anywhere. Like, it seems like it's so much harder than it is. And then as soon as you get, oh, okay, the ball is supposed to go in the goal, then suddenly almost all of the running that players are doing and where they're going just makes instant sense. Like, same thing here. As soon as you realize this is the point, as soon as you have a goal to run at, then a lot of stuff will just fall into place. You'll realize these problems are not as complicated as you think they are. So, okay, statement one. Okay, well, this means the team won the first 39 games. Well, 39 of the first 65. So this means of the last 35, we don't know. So can you get 50 or more? Well, I mean, let's just take extreme possibilities and just see what happens. So yeah, the extremes are, you know, first extreme is 39 wins out of the first 65 games. And then 0 wins in the last 35 games. So that means 39 wins. And then the other extreme would be 39 wins in the first 65 games. And then you win all of the last 35 games. So that is the total of, that's, I don't know, 35 plus 39, whatever. The point is that it's more than 50. And again, I mean, I'm not super great at mental arithmetic. So the point is I don't need to waste my time even figuring out that that's 74. Because, again, that's not the goal. The goal is not calculate numbers. The goal is I know it's more than 50. So I don't even care what it is. All right. Statement one is not sufficient. Statement two is also not sufficient for the same reason. It's the same numbers. So you can just switch first and last in the above reasoning. So it's not sufficient. So if we have our grid up there, then A and D are out, and then B is out. Now let's combine them. So let's be organized about this. I mean, the deal here is that in the first 65 games overlap with the last 65 games. So that's not really the kind of thing that I would want to keep track of in my head. So let's just make a diagram where it's like, okay, this represents this number line thingy represents the season of 100 games. And then the first 65 games, yellow and blue makes green type of thing. The first 65 games can be this yellow streak right here, and the last 65 games can be blue. Okay, I guess yellow and blue doesn't make green, but I tried. So this is, how many games are in that overlap? I mean, you can think about numbers of games, right? This would be game 1 right here at the start of the season. So this blue region starts, that starts with game 36. And this ends with game 35. I mean, because remember, the blue thingy is the last 65 games, which means this is the first, the pure yellow part here is up to game 35. And then this ends with game 65. Because that's the yellow part is the first 65 games. So, and then that pure blue part here is 66 all the way to game 100. I mean, you don't have to necessarily number them like that, but there are 30 games in the overlapping part. And there are 35 each in the not overlapping part. So let's do this as an extremes type of situation. And again, extremes is not, you don't have to memorize that you'd want to do extremes here. Because again, if you have the goal, this is why you do this. Like, okay, I'm trying to get two things to happen where one is a lot of things and one is not a lot of things. Like, if you know that this is your goal, then the whole extremes approach will just kind of happen. It'll just like fall out of the problem with no effort. But if you don't know what you're doing goal-wise, then it won't. So this is really important. So let's try extremes. One extreme is that one extreme is that everybody wins all of the overlapping games. So this will be 30 wins. So to make these statements work, then you would only need 9 extra wins in the other part. Because you have to win 39 of these games, but you also have to win 39 of these games. So that means 9 wins here. And that means 9 wins here. So this is 48 wins. That's low enough to be under 50. So now we need to just try to get it to be over 50. So let's make that happen by having as many wins as possible in the not overlapping part. So you can win all 35 of these games. And you can win all 35 of those games. So then that means you only need to win 4 of these. So that's definitely more than 50 wins. So it looks like we got both ways. So, which is still not sufficient. And overall, this is our friend E. So yeah, this problem's not really about percents, but you know, it looks like it is. And I mean, in terms of the rephrasing, if you want to call it a rephrase to go from half to 50, then that you can call it a rephrase if you want to. But just make sure you know the important part is I gotta know what the heck I'm even trying to solve for. Sounds obvious when I say it that way. But yeah. Paul says, Paul, you got to be careful not overgeneralizing the idea of a trap answer. I mean, you know, the C is not a trap answer here. I mean, it's not such a trivial looking thing that someone would be like, oh, obvious. I mean, you got to limit your idea of a trap answer to something that is so obvious looking that it like jumps out at you, even if your knowledge is incomplete. Like that whole thing with 75% more and 75% less, so that other problem. Like even someone with a very tenuous knowledge of percents would think that looked obvious. Here, I mean, I don't know, nothing jumps out at me as particularly trappy about C versus E here. I mean, there's definitely nothing that appears super obvious to the common sense thing. So, not really. And if you tweak the 65 even like a little bit, then I think it winds up being sufficient. Like, if you change that number by a really small amount, then you can't get to below 50 anymore. But you know, try it. Try making it 75 or 60 or 70 or something and see what happens. All right. So, because one thing that's interesting about this problem is that if this number goes down, then it'll become C. But if this number goes up, it'll also become C. Like if these are 50 and 50, then that would mean no overlap, and so it would mean they won 60% of everything. So that would be C. And then if these were numbers that were close enough to 100, then they would have to win enough games in the overlap that it would, again, have to be more than 50. So the number 65 here is sort of magical. So it's interesting. But try it, you know, try throwing a different number in there and just watch what happens. Like, I don't know exactly where it would switch from being C to being E, but the point is that it would on both sides. And again, when you review the problem, you can do stuff like that. I mean, you can actually change the number and then see what happens. The disadvantage of doing that, of course, is then there's no answer key anymore because you changed the problem. But it's more of the let's try to get as much learning as possible out of this thing that's in front of me. So, yeah. All right, we are a little bit over time here, so we're going to quit it. But thank you for attending. So we didn't get to do any of the sentence corrections today, which means that is probably going to be the next study hall topic. I think the recordings are available. I mean, it's whenever the tech people get a chance to post it, but I believe that it is usually the Monday that follows. It's somewhere around there. So, yeah. Okay. I don't know about Venn diagram, but I'm Guang, if it's maybe you could take a screenshot of it or something. Which problem was it? I don't know which problem that problem is. Venn diagram, I don't know how you would do that because this is not a Venn diagram type of. Maybe you could. I mean, I guess you could have a Venn diagram that would just be like a kind of same thing as this thing we have as a number line. I mean, you could have. I mean, that could be a Venn diagram circle thingy, and then that could be another one. Yeah, you could do that. So yeah, it could be a Venn diagram, Veronica. In fact, yeah, it's the same as what we got here. Ninad Shah, the recordings are on the Thursdays with Ron page. There's links to them. You just scroll down on that page. And they don't go up right away. They go up the following week at some point. All right. Okay, but Veronica, as long as it makes some sense now. All right, someone asked about the 1.75. I mean, we got a few slides of this guy. We got like 4 slides of this. So, Guang, which one did you want the screenshot of? That one? Okay. All right, so we're going to kill the recording at this point, and we're going to start winding this down. Good night and good luck. And the next study hall, I believe the next study hall is just 2 weeks from this. So have fun. I'm going to kill the recording here and start winding it down.